Fantastic. We'll go back to the beginning there. So we have the opportunists, and so those are coming in and they're breaking down what's left. They're colonizing the bones, they're living off of the bones, and they're going into the sediment as well. And sometimes that's bacteria that's creating a bacterial mat on the sand, and sometimes it's worms, it's all these different cool things. After all of that, we have our third stage where only the bones are left. And after that, when it's just the bones, there are organisms that come in, typically worms and also like bacteria, lots and lots of bacteria that come in and break down the fats that are in the bones until eventually next to nothing is left. There's some hard parts left, but they're very much like falling apart. There's no fatty bits to them that are kind of giving them the structure that we typically think of. This third stage can last for up to 50 years. So if we're at our max right now, we're at almost 60 years. We're at about 57 if this is all taking as long as it can. So, and that's assuming that there are organisms that find this whale as soon as it gets there. It's an incredibly long process. Our last stage is what's called the reef stage, where all that's left are these artifacts of the bones, not even the real, like full bones, not even the full skeleton. And it just provides a harder surface for organisms that are sessile or non-moving. That they will go and they will stay on. And this is pretty much to no end. So these are a great opportunity for things that are filter feeders that don't want to move around and swim or move with the current, but need something to latch onto on the bottom. And so typically that only happens in areas where it's very rocky. So this provides them a great opportunity. It is providing a home for so many organisms for years and years and years. And we haven't even touched on, okay, now we have the six-gilled shark that is here eating at this whale fall. But what if there's another fish that six-gilled shark could eat that's eating at this whale fall? Or what if the octopus that's here also eats crabs that are at the whale fall? And so they're getting all these different opportunities for food that they wouldn't normally get in the deep sea, and they wouldn't have this readily available. And it's all because of one whale. We're gonna keep going. So, where do whale falls occur? Whale falls can occur pretty much anywhere. They typically occur in the deep sea, and that's because in order for a whale fall to occur, it needs to be in a high pressure and low temperature environment. So it needs to be cold and there needs to be a lot of pressure, and it helps preserve the whale from decomposing. And that allows these organisms to get there and to feed off of it. So you can have a whale fall in shallower areas. It does happen. Typically, it only happens in very cold, shallower areas. And that's because you want this whale to be there for quite some time. It's not going to be a brief thing. Sorry. And so with that, we typically only see them in the very deep sea. And it also makes sense that we typically see them along whale migratory routes. So there's a higher abundance of whale falls where there are more whales. Pretty self-explanatory. The carcasses can be carried for some time by currents before they sink. But it's not necessary that, like, if you see one that's out of the ordinary, it could be because the whale died there, it could be because the current carried it in some way. So they typically end up, though, in the very deep sea. And we're going to take a look at a map of where these occur. So this is a quick map looking at known whale falls as of May 2022. And if you look at the key that's over here, the legend that tells us about these whale falls, there are three types that are noted on this map. Natural whale falls, which are that little golden pin. Fossilized whale falls, which are that purple star. And you can see some of those happen in some pretty unique places as well. And implanted whale falls. Implanted whale falls are pretty much a whale fall that happens because we took a dead whale and sank it in that area. And the reason that we do that is to study what happens at these whale falls because they're in the deep sea. They're incredibly hard for us to access. We don't just end up in the deep sea all that frequently, hopefully, fingers crossed. I don't know what you guys do in your spare time, but we don't typically find them. They're very inaccessible for us. So we will implant them to see how do they happen in shallower areas? How do they react in colder air environments than we typically see them? What happens to the species in this area when we have a whale fall, to study what that succession looks like, to see if animals that we might only expect in the deep sea will actually, come towards a whale fall that's a little bit shallower, if they're able to withstand that. There's so much really cool research that goes into implanted whale falls. And that's how we know that they can, in fact, happen in shallower areas. What we do see a lot with those implanted whale falls to study if they happen in shallower areas is that there's a lot more current. There's a lot more what's called sedimentation, where sediments pile down, usually from erosion on land, from landslides, from just mudslides underwater. These typically happen closer to land masses. And so those carcasses that are under the water that have been weighed down will get covered in sediment much faster. Also, when it's shallower, it tends to be warmer, which speeds up the decomposition process. So that's why we tend to see them a little bit deeper. With that, we're going to take a look at one whale fall in particular. It's a little bit closer to home. So this is Davidson Seamount. Davidson Seamount is off of Monterey. It's part of the Monterey Bay National Marine Sanctuary, which is a mouthful. And there's a whale fall that occurred in Davidson Seamount, and we found out about it because there's this organization that was going to do a research expedition, and it's called the Ocean Exploration Trust, and they do amazing work. If you're ever bored, just go Google them, and you can watch amazing videos from their explorations. So they work with the Nautilus Exploration Program. And they have this boat called the EV Nautilus, or the exploration or exploratory vessel Nautilus. And their whole goal is to explore the ocean, to seek out new discoveries in the fields of geology, biology, maritime history, archaeology, and chemistry, while pushing the bounds of education, outreach, and technological advancement. Everything that they do is live streamed. So they will live stream on YouTube, they record these videos, and they show what is going on at the seafloor, and they're mapping on the seafloor. And it is phenomenal stuff. They work with this vessel and 2 ROVs. If you're not familiar with ROVs, it stands for remotely operated vessel, or vehicle, depending on who you're talking to. This is an ROV here. This is the Nautilus's ROV. This is Hercules. They have Hercules and they have Argos. Hercules is their main one, Argos is their little one, and they're tethered together. So ROVs are really cool because they're connected to your boat and you are driving them around as you go. So you can move around, you can change the angle of your camera. It is like having an RC car that is underwater. We have one here at the Ocean Institute, a little one. We named him Stephen. He's like that big, and we love him dearly, and we use him for school programs. And so he also has a camera on him so you can see where they're driving. But we do that in our big ROV tank, which is significantly less exciting than a whale fall, in my opinion, anyways. So part of this exploration was to explore, like I said, Davidson Seamount, because they were going to characterize what they called an octopus garden, which was an area of unexplored deep water basalty rocky reef area where there were octopus just breeding at this insanely high volume. And along the way, they stumbled upon this whale fall. So we're going to take a look and watch some of the video. Please give me a thumbs up if you can hear the video once it gets started. If it loads. There we go.
Wow. Octopus.
Oh,
Whale
whale
fall.
fall. Here we go.
Oh, whale fall.
Oh, here we go, baby. Okay,
Yes.
Kimmy is phenomenal.
We can't stop, can we?
We
We
are-
can stop and come back if you want.
It'll,
Yeah.
I think.
Oh,
Like,
let's take our time with it, and then
I
we
think it's
have to
worth
come
it.
back anyway.
Yeah.
So.
Video.
Okay.
Oh
is
my
amazing.
god.
Okay.
So
Okay, I can't hear
many.
Greg.
Yeah, this is
No
worth a stop.
way.
This
That's
is like
worth-
a baleen whale, and you can still see the
Yes.
The
baleen.
baleen is
Yep.
still there.
One,
Oh,
two,
this is
three, four,
great.
5, 6, 7, 8, 9, 10, 11, 12.
Someone
count
who has Twitter, tell
15
Twitter if you
octopus.
don't have one.
Somebody tell Twitter. Twitter is with us right
Oh
now.
my
They see
goodness.
Look at them.
Wow.
Wow.
Whew. Brief pause.
This is
So
incredible.
yeah,
Talk
this
about
is.
Shower.
When you zoom on
The
bones,
dinner
they look
bell
like they have
ringing,
the
right?
specs. They
Yeah.
might
We are
already
so
have.
excited up here, just
Greg,
saying.
can I zoom?
Yes. Come
Yeah,
and
let's
get
go ahead
it.
and zoom in.
Yeah. Dinner is
Do we have
served.
any
And if,
bone-eating worms?
Bridge, if we could track a line back.
Can you guys still see the video? Okay, we stopped. Brief pause. I don't know what just happened.
There's not any red tentacles
or anything yet. Some brown fuzz on the vertebrae.
Yeah.
I mean, on the ribs. So those might be.
Yeah, approximately.
Oh,
this.
Brief technological difficulties. I don't know where the video has gone.
Circle
It's
is 450 meters.
I mean,
Yeah.
look at the Argus
you're right.
view.
You're right.
Yeah, look at the Argus
Argus
view.
Can I zoom in? Argus?
So what do we estimate the length of that?
Yeah, how long is Hercules?
2.5 meters.
Well,
2.5 meters.
in length from forward to back. Yeah.
So this looks like maybe a 4 to 5 meter whale.
Yeah, yeah.
It is still soft tissue.
Yeah.
There is.
Definitely was something.
All right. Well, people watching, we'll definitely come back here if we're swinging a little too far and spend some time.
Okay, you guys cannot see it. So I'm gonna try that one more time. Give me one moment. I'm so sorry. Okay, there you guys are. Fantastic. Okay. Give me 1 second. And we'll keep going.
Here, this is definitely worth it.
Yeah, mark the target.
I wonder if
and,
this is some of
we'll
those
go past
octopus's
it and
last
come
meal
back.
before they make their way over.
Ah, that's a good point.
Yeah.
Hi.
Well, we should
Hi,
get
octopus.
the sexes up.
We'll come back.
Yeah.
Don't worry.
Okay, so
Goodbye.
what's
Still the fat
happening?
at the tail.
There's
Amazing.
fat at the tail. Yeah.
Goodbye, octopus.
Yeah.
Okay,
This
this is
this
awesome.
is-
Just partially digested still.
This will actually be
In the
pretty
thick
good
of it.
because on
So
the way
come up.
we'll go down the slope, and then on the way back we'll be able to go hit the slope back
Look
up.
at the sediment to the left of the whale.
Yeah,
It's
there's
got-
something on it growing.
Yeah.
There might be some of those worms.
Yeah, bacteria mats, worms, something.
Yeah, I'm thinking bacterial mat of some kind.
Look at
Look at
Oh.
Oh,
that.
that's not
Worms.
bacterial mat.
No, they are
That's
worms.
worms.
Yeah.
Look at that.
So yesterday we were talking about seasonality in the deep sea and how episodic falls of food are a bonanza, I think is the word I use.
Bonanza,
So if
yep.
you come around
And here's a
positive
bonanza.
This is a,
and
yeah.
basically
I'm so
spin
sorry.
around
I
and
have no
then
idea.
you give me
Oh,
back
this
the
is
view.
great.
Just think the amount of calories in a whale here. I mean, the equivalent of so much marine snow. It's hard to even compare.
Oh, look
you know?
at the blubber on the right side.
Yeah.
It's not
Yeah,
even digested all the way. This is
Oh, yeah,
so cool
this
to
is
see it
still
partway through. Okay, so what's happening is the ship is tracking the line and moving along as we're moving towards the cone. So the ship is moving Argus away. Hercules only has a certain amount of tether away from Argus. So as the ship is moving, we can't
And
just
those are
immediately
worms
stop.
in there.
Mm-hmm. So
And
we're
the
gonna
baleen.
probably pull away from this a little, but we're in the process of stopping and turning the ship back around and coming right here.
Yeah, we're about 450 meters, so the ship is now coming back. So we're going to get pulled towards the ship and then back. We'll do a little yo-yo.
I'm surprised
and
there's
then
no
we'll come back
sharks.
here.
So whale falls are a really cool way to think about the ecological idea of succession. So after the whale, look at the bone.
So what is the fuzz on those bones?
Yeah, the fuzz on those bones are, let's see, the
Hydroids?
common name I remember hearing was the bone-eating snot flower worm,
Uh-huh.
but the genus is Ossidax.
Ossidax. Yep.
So these are worms that have symbiotic associations with bacteria. So they have no more gut themselves. Instead, they have these rootlets that burrow into the bone, and then the bacteria are able to metabolize the fats and oils that are in the bone itself.
Wow.
Yeah, my colleague at Imbari, you know Shannon Johnson,
Shannon
right?
Johnson.
She's worked a lot with these bone-eating worms. She's been a part of naming several of them. One of them was after Pink Floyd, actually. I forget the name off the top of my head. I'll find it. But yeah, she would be going. We're all.
So we're gonna pause there because I could continue watching this video forever, but there's still so much more to talk about with our whale falls. So that is just one video of one, and that one you can find online. If you look up whale fall videos, it's going to be the main one that is going to pop up. So this happened in 2019 that they went and explored this. And it is a super fascinating exploration, and we love it so much. So, kind of moving on. Why do we care about whale falls? So whale falls, on a very surface level, provide some insight into deceased whales. We understand, okay, where are whales dying? We can see sometimes evidence of, was there before it has been scavenged? Were there massive traumas to the whale? Is there fishing gear that is found around the whale fall? Something that might provide some insight into how that whale died, but also what happens after they die. How far are their carcass carried? How do they end up at the deep sea? What does that decomposition look like? Lots of different questions there. But it also provides insight into deep sea food chains. Like we talked about, exploring the deep sea is incredibly difficult. Like, it is incredibly expensive. It requires a lot of manpower. It requires a lot of technology. That used to be a time that we would go and be able to take submersibles down there as people. But when you go down in a submersible with a human being, you have to worry about, do they have food? Do they have enough air? Where they're going to go to the bathroom? How long can they stay down there? Also, if something goes wrong, then you have people who are unfortunately possibly not going to make it. So these are all things you very much have to be worried about when you send people down there. So instead we send little robots down there called ROVs, or AUVs, autonomous underwater vehicles, which drive down there and don't require someone to be controlling them. And they're very expensive. They cost so much money to make. And then if you lose it in the deep sea, it's gone. So these are all things that we have to consider. So finding whale falls and getting to know more information about these deep sea food chains is so difficult, but so important, because it is this massive area that allows us to see so much into that deep sea food chain. Whereas if we're just driving along and you find some dead fish or something like that, you're only getting a very small snapshot of what is happening there. So, yeah, whale falls are incredibly important when it comes to insight in deep sea food chains. On a more broader level, too, it provides food for organisms in the deep sea. They are so important for these ecosystems. They become the basis for many ecosystems in the deep sea and for massive food webs, all in that little area for years. Like we said, for over 50 years. So whale falls are so important when it comes to the deep sea. To us, it's great. It allows us more information, but to animals in the deep sea, it is a once in a lifetime thing, multiple if you're lucky. With whale falls, it also gets into a really important topic, that is, whales are what we call a carbon sink. So whales are, first of all, amazing. Second of all, they play this massive role in carbon storage. So if you think of trees in a rainforest, or even just marine algae in a kelp forest, whales are efficient at capturing and storing carbon from the atmosphere into their body throughout their long lives, because they are consuming massive amounts of phytoplankton throughout their life, which then is digested into their body. It goes towards their fat stores. It goes towards their muscle. It goes towards them growing and storing all of this biomass. They live also incredibly long. So because they live so long, they are storing this for, in some cases, over 100 years. So that carbon is really being sequestered into their body, and it's prevented from returning to the atmosphere as carbon dioxide, except for when they breathe. But they don't breathe terribly much. So for reference, these whales store more carbon in their bodies than trees. One whale can capture, on average, 33 tons of carbon dioxide over its lifespan. A live oak tree, which is one of the most efficient carbon capturing tree species through photosynthesis, captures only about 12 tons of carbon dioxide over its lifespan. But an oak tree also lives for a maximum of 500 years. So whales are incredibly efficient at storing all of this carbon in their bodies. Not to mention that while they're living, they do this fantastic thing called the whale pump, which between their cycles of diving and coming back up to the surface, they are pooping large amounts, which is stimulating things like plankton blooms. It's providing all of these nutrients for plankton. So it's super, super interesting. They provide all of this food for plankton throughout their life. They're capturing all of this carbon. And then after they sink the whale fall, they capture all of that carbon and kind of lock it into their bodies at the bottom of the ocean. And instead of it ending back up in the atmosphere, it goes into the organisms that are then eating the whale fall. So ultimately, whale falls sequester carbon. They take it from the atmosphere and kind of keep it away from the atmosphere for hundreds to thousands of years. There are so many deep sea organisms that have evolved to rely on nutrients specifically from marine snow. And so whale falls are responsible for a huge amount of those nutrients because they're massive. And so as they're decomposed and as they're eaten by deep sea animals, that carbon is sealed into a lot of those other organisms. It's even sealed into the sediment that is there. And so it prevents it from returning to the atmosphere. Super interesting stuff. I also could talk about whale pumps forever. But that's also why we care about whale falls, is they're doing, believe it or not, amazing things for the environment. There are great ways to help protect the environment, and we always talk about planting trees, but saving the whales is so important when it comes to fighting things like climate change and fighting things like large carbon emissions in our atmosphere. The whales are going to do so much, so we have to protect them. So why and how is this actually relevant to us? Great, we talked about climate change, we talked about how it's relevant to the deep sea, but on a more surface level, why should we care in our day-to-day? So let me tell you. In 2023, researchers mapped out 135 square miles of seafloor in San Pedro Basin. And this area was known as an industrial dump site, particularly for DDT between 1930 and 1970. Some of you guys might be familiar with this already, but for reference about where San Pedro Basin is, it's between two harbors and the port of LA. And so this basin here was used for a chemical dump site. And DDT was a really toxic chemical, and it's still in the water. And when this dumping was occurring, we were seeing massive die-offs of pelicans. And it's something that we talk about a lot here at the Ocean Institute, because it's something that we could visualize a lot better, is that the years following this too, for years we saw these massive die-offs of pelicans because DDT binds with calcium, and calcium is what pelicans need to form their eggs. And that calcium, if they don't have it in their eggs, what's happening was they were sitting down on their nests to incubate their eggs and crushing their eggs because there wasn't enough calcium in there to support their eggs. So DDT is incredibly harmful. And if you can imagine what it does to bird eggs, you can imagine what it does to calcium that you need in your bones, that you need to keep your body alive, that you need to give you energy. It's all very important in your body. It's a really reason that we talk about it being such an important nutrient for us. So this area is famous, and we're still trying to fully understand what the effects are from this area on, in particular, mammals like ourselves. And we know a lot about the effects of DDT, but long term, we're still, excuse me, we're still learning, because this only happened almost 100 years ago was when it started. So there's still so much to learn about this. And with that, when they mapped out this area, 7 whale falls were photographed just in this tiny little area. However, using sonar, they mapped out and expect there to be more than 60 in that area. We don't fully know if these whale falls are a direct result of that DDT and if it was causing whales to die in this area. It is very possible, because in this area there is very low oxygen, that very much would have slowed down decomposition. And because of the currents in this area, and I hate to say it, but the way that the seafloor is in this area, there's not a lot of sedimentation. So it's not as fast that we see burials of these carcasses by sedimentation. So it's also very possible that these whale falls have accumulated over many decades, that they're not just from the 1930s after they started putting DDT here. Unfortunately, because there's so much decomposition that has already happened, we aren't entirely sure, and we really won't know. But it's something that we're trying to learn more about as we're looking at the impacts of DDT. Could this be a sign that it is affecting large mammals, and could it be something that is ultimately going to affect us? You're totally fine, Kenna. You can head out. We're about to actually wrap up. So on that very happy and cheerful note of DDT, I'm going to bring us back to our next and last part, which is another video. And so this video is going to be talking about that same exact whale fall that we watched earlier. When it loads, if it loads, we're going to see. And we're going to look at, like we said, that succession and see how it's changed. So, fingers crossed. There we go. Let's take a look.
Check, check. This is an audio check on SPL. Good afternoon, everyone.
Well, Bridge just called.
Yeah.
He found it in the logbook, and we're on the exact coordinates that they had for the whale fall site.
Where is it? Yeah, I kind of see something in the distance there. It's barely out of view.
I'm pretty sure this is it. Right, yeah, and the sonar right ahead of you.
That's it. Score.
Woo!
All right.
All right. Okay.
Maybe. I wasn't worried.
Dropping a target here for sure.
Drop targets all around it.
Yeah.
Oh, wow.
Yeah, so different.
It is so different.
3D model we do will really show the volume change, I would think.
The rib bones just kind of disintegrated there.
Yeah.
The whole rib cage was supported last year. I mean, it was still upright, everything.
Wow.
Yeah.
The video. So we're good on video too? Definitely not as many worms in the sediments around it. We'll have to look closer to see if there are any
You
left.
guys can't see it at home,
Last year it was a pretty obvious carpet.
but yeah.
So that's one piece, right?
That's
Correct.
one
I think that's
piece
one
right
piece.
now. If you want to get more, we
Yeah.
can add more to this sample.
Yeah, we can.
Great.
Yep.
And that one, Mo, that one does have the limpets on it. jumping ship.
Yeah.
Yeah.
Awesome.
And here we see some bone-eating worms that are not in large clumps, but more individuals.
Just spell or write what the name of this bone is so I can record it properly. Okay.
Humorous.
Not in that it makes you laugh kind of humorous.
Yeah, that's the ulna. That's your funny bone.
Okay.
The grenadier is very interested to watch. Don't let it make you nervous.
Oh, there you go.
Oh, there you go.
Spoilers.
That was really good.
Can we do the carousel?
Wow.
Okay.
It's very much like the
Let's
claw
see. I'm
game.
impressed too. Mo says, I'm impressed.
For anyone watching out there on the internet, we're going to wave goodbye to the whale fall. Bye, Mr. Whale.
Bye, whale fall.
Maybe Miss
Bye,
Whale.
whale.
I don't know.
Come down.
We'll see you next year.
We'll see you next
Maybe, maybe not. Decomposition's happening really fast.
Yeah, might not be much left.
And so that kind of brings us to the end of our talk about whale falls. As you can see how much changes at these whale falls and how both quickly they can disintegrate, but also how much life they support. So these are incredibly cool organisms. And that whale fall will, kind of like they mentioned, will probably be there for years to come and has probably been there for quite some time and will continue to provide food and resources for the organisms that live in that area for years to come. So yeah, that is our whale fall presentation. I'm going to stop sharing my screen, but if you guys have any questions, please go ahead and ask.
That was really interesting. Thank you. I love that video. That's amazing.
I am telling you, like, if you're bored or if you want to learn more about the ocean, that website, you can just even look up like Nautilus Live is typically what their like YouTube videos are under. And they do incredible videos, and it's way more than just whale falls. They go all over. They do expeditions all over the world. They've been doing them for years. And they're so much fun to watch, and they're so educational.
Very neat.
Yeah.
A question, if I may.
Yeah.
So, from my perspective, it's a very interesting presentation, by the way. But from my perspective, what I've seen in real life is when a carcass washes up on shore, they immediately try to bury it in the sand as opposed to finding a way to take it out and create a whale fall in a local area. Is that because of the local requirements or rules or lack of logistics to be able to do that? It seems like there could, if there's such a benefit to that for the ecosystem, it seems like there should be a resource or find a way to be able to transport it in deeper water, or is that just a wishful thinking on my part?
It's a very loaded question. I'm going to start there. So already when a whale washes ashore, there is a lot that goes into it. That's typically where you see stranding networks that come in. And depending on the whale, the size of the whale, and the organization, they will most times try and do a necropsy or collect some samples. In some cases, that means that they remove the whale from the beach and collect it for necropsy. And once they've removed it from the beach and bring it back to a facility, they can't then bring it to bury it or to release it like out into the ocean. In particular, because a lot of times when they're collecting that for necropsy, it's going to end up coming into contact with preservatives and with chemicals and stuff like that. They don't want to then put back out. Also because a lot of their permits don't allow them to then dispose of carcasses out in the ocean. That's just one part of it. When they bury them on the beach, it's a lot of times because, one, refloating a carcass can be really complicated. Because if you don't do it right in the way that you know it's going to sink, it's just going to wash up somewhere else. And sometimes that can pose a human health hazard. And so the easiest and most guaranteed way that we know that it's going to be out of the way of humans and kind of less of a health hazard is just to bury it on the beach at a depth that won't become something that's eroded or by some way excavated by humans. It also is because bringing a whale out into the ocean, you typically requires very, especially once it's made its way onto land, very, very large boats and machinery. And once you are trying to kind of tow a whale out, you have to be able to attach like the ropes and the chains to a whale that is essentially, I hate to say it, like falling apart. It is decomposing. And so it's never a guarantee, too, that you're going to be able to do it. And as you're towing that whale out, it is literally at times tons. And so it can be more than a boat can handle, especially because the larger boats that would be able to tow out a whale like that won't be able to get close enough to shore in order to then drag it off of shore. So that's like a very large, the logistics of it are so complicated because you have to be able to get a boat close to shore without it running aground that can be big enough to tow the whale and attach something to the whale in a way that it's not going to just also like rip from the friction of the whale on the beach. And then it has to be in a like disposed of in a way that you know it's going to sink and it's not going to end up refloating and rewashing back onto a beach somewhere else where now you've spent all this time and resources to float it the one time and now you have to do it all over again, and hopefully you only have to do that twice, but you never know. So when they do it for research to intentionally bury these carcasses, or I'm sorry, to intentionally sink these carcasses, it's typically done with a lot of funding for research, and that's how they're able to do it. And it's done in very particular areas because, like, at least here in the Pacific, we do have a pretty quick drop off, where you might be able to get a whale that ends up being deep enough that you have the right characteristics for a whale fall. In many areas, it's also not the case. So you end up just kind of dragging it out. And if you manage to get it to a point where it does sink, then it's just going to end up getting covered by sediment and doesn't have the same benefits as if it was in the deep, deep sea, which would require you to then drag it out really far. So does that kind of answer your question?
Very, very good answer. Thank you very much for the clarification.
It's so complicated and it's so convoluted. And then also half the time, nobody really wants to deal with the stinky dead whale towing behind their boat either for quite some time. And it does also attract a lot of things like sharks, and other large animals that people don't typically want to be around. So that's also why they're like, I'd rather just bury it where it is and not have to deal with it.
So what happened with Lily the whale? Because I was there on the beach when she was beached, but they were trying to tow her out, but I know they were having a lot of trouble, and I don't know what happened in the end. Do you?
Which one? Who was Lily the whale?
Lily? I don't know. It's maybe about 10 years ago. So
predates me. I'm recently to the area, but did she strand live or was she already deceased?
As far as I know, she was deceased and washed up on Doheny.
Probably what happened was, and it really depends on the beach too, and the type of whale. It's very possible that if it was a small enough whale, they were able to collect it. Doheny doesn't have also super great access to get large vehicles that could tow a whale off a beach, like to a lab. So it's also very possible that they buried her there.
I'm wondering, I'll have to look that up, see if I can find information.
Yeah, sorry, I don't know any more about that one in particular.
That's okay. Yeah, the one boat is named after her. The whale watching boat.
Yeah. Yeah, it's a very like there's so much that goes into it. And then like can you even get the vehicles onto the beach that would be required to bury it is a big issue in some places. And so there are areas where you just kind of hope that it's going to wash back out after decomposing a little bit more. So yeah, it's stinky and gross. But there's a lot that kind of goes into those decisions.
Interesting.
Yeah. Yeah. Any other questions? Okay. Well, thank you guys so much for coming. If you guys have ideas for next month's continuing education, please share. I want to talk about what you guys want to learn more about. It makes it way more interesting for all of us. So please reach out if you're here on weekends or if you're here during the week, mentioning it to someone. Excuse me, you can always email myself or Sophia. My email is just enewcomb@oceaninstitute.org. And email us if you have topics that you'd like to learn more about, anything like that. Tell your leads, tell your person, your point of contact. But yeah, we'd love to talk to you guys about what you guys want to learn about. Otherwise, I will keep talking about probably marine mammals because that's what I love. So get ready for lots of fun presentations about whales.
Thank you so much.
Thank you guys, and I hope you enjoy the rest of your day. Have a happy and safe Halloween.
You too. Thanks.
Thank you guys.
Bye.